Okay, next thing we want to do is just review quickly here the quadrant properties, which we talked about before, but let's just make sure that we understand again here that the right side of the graph is positive, the top of the graph is positive, the left side is negative, and the bottom is negative. Now, if you remember that sine corresponds to y, and anywhere y is positive, sine will be positive. So you'll notice y is positive up top, so sine's positive on the top. Sine's negative on the bottom of the graph. Cosine corresponds to x. So wherever x is positive, which is the right side of the graph, cosine will be positive. And wherever it's negative, on the left side, where x is negative, cosine is negative. Now, tangent is just sine divided by cosine. And we've seen that. So, sine is positive, cosine is positive, tangent will be positive. Wherever the signs of sine and cosine are positive, are the same, tangent will be positive. Wherever the signs are opposite, so here you have sine is positive, cosine is negative, that means in quadrant 2 you're going to have a positive divided by negative, tangent is negative. Okay? So we want to make sure that we understand where sine, cosine, and tangent are all positive or negative. And leads us to our next example, where we have to use some of this information to help us out. Look, they're going to tell us that tangent here is less than 0. That means tangent is negative. Okay? Now, first off, that narrows it down already to two different quadrants. It's either going to be in quadrant 2 or quadrant 4, because those two places are where tangent is negative. Next, they tell us that sine is 4 over 5. Well, that's implied that sine is positive. So, the only place where tangent is negative and sine is positive is right here in quadrant 2. So we know we're dealing with a situation in quadrant 2, and so when we go to set up our drawing, which is going to be crucial, I think, in this problem, we know to set up our drawing in quadrant 2. Now, we know that the sine of this theta, which is ending up here in quadrant 2, and again its reference angle, which is in here, is 4 over 5. Okay? We want to evaluate the other 5 trig ratios. Well, we have 4/5 there. We have to find this missing side. If you use Pythagorean theorem, you'd find that it's 3, but again, since it's in the negative direction, we need to call it negative 3. Okay? So, once we have that, we can just evaluate each of these based on this reference triangle that we made. Cosine of theta is going to be the adjacent over the hypotenuse. Okay? So negative 3/5. Tangent is going to be 4/3. Opposite over adjacent. Cosecant is going to be just the reciprocal of sine. Cosine is the reciprocal of secant. And cotangent is the reciprocal of tangent. Pretty simple.